Okay, so yesterday we learned an inverse function, which if your original is this, then this tells me it's an inverse. That was the language that was used. Okay? If your original has a coordinate xy, the inverse has the coordinate. What do you do with the coordinate? Yx. Okay, so that's what the inverse was all about. So if I look at this one, this is the coordinate 1, 0. So what coordinate should be on the other one? 0, 1. Okay, do you see that? And what else did we visually see happening? Do you remember? A reflection diagonally. Okay, do you see it physically with this? It reflects diagonally. So you might hear inverse. You might see this, which means the same thing, or you might see reflection over y equals x. Those three things all mean the same. An inverse, f negative 1 of x means inverse, or reflecting over y equals x. That's the equation of this yellow line, because it's a line with a slope of 1. That's why it's y equals 1x. Okay, if I was to talk about invariant points, would there be any invariant points from the original to the inverse on this? So this is the original and this is the inverse. Is there any coordinate that would be invariant, didn't move?
The 1, negative 1. No?
This coordinate right there. What's that? I don't know what the coordinate is. I think it's something like, should we go 1.3, comma 1.3. So physically, what do I see about the coordinate? 1.3, comma 1.3. It's the same. So if I flip 1.3 and 1.3, switch them, it's going to be 1.3, comma 1.3. So if you ever see any coordinate that is anything like this, 6, 6, when you flip it, doesn't change. Okay, so that's what we learned yesterday. Now let's talk about inverse equations. Okay, we know that f of x really means what? What'd you say? Just y, yeah. And f of x is really the y part. Coordinates usually, so when I see this, when I talk about this as a function, it means x is the input, f of x is the output. That's what this function talks about. And f of x is really just the y. Okay? Of course they have to make it complicated looking, right? Okay, so what I'm going to do is, I'm going to just rewrite this y equals instead of the f of x. Okay, now we're gonna inverse. What does the inverse mean to you? Tell me in words, what does the inverse mean to you? What did you do here? Flipped the x and the y. Let's say switched. Can we use that word? Switch, which means switch x and y. That's what inverse means in words, right? We switched the x and the y around. So what will yours look like? X equals 3y plus 2. Okay, now normally when we say functions, we would have y equals alone and blah, 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 blah. So what kind of algebra can I do to get my y alone? Minus 2. And divide by 3. Okay, so now let's remember what the language was. The original was f of x. So now this is f inverse of x equals okay, so the steps were making sure you switch the x and the y. That's the answer. That's the new function. Yep, write the equation for the inverse. So switch x and y, and then get what your new y is going to be. Okay, so here we go again. I'm going to just rewrite it. Instead of having the f of x in there, I'm just going to rewrite it with a y. Okay, ready? To inverse, write that with your x and the y switched. Now we're going to work to figure out what this y is alone. Okay, so I'm going to go times by 5. Okay with that? Times by 5. And then I'm going to still need to square root. And then do you remember when you square root something like that in math? You're going to do a plus minus. Okay, but language-wise, I'm going to go okay, I'm going to do one more question with you because I put this one on your test. So can you give me a little box here? No, well, not the exact, but... There, this question. Okay, so I added one extra half step to what we just did. Okay, so given the original function, so the original was y equals 5x plus 1. That was the original function. So I'm going to get the inverse function. So what's my process of getting an inverse? Switch and isolate. So I'm going to -1 and divide by 5. Okay, what does this mean to you? You learned this stuff in grade 10, but what does this mean to you? When you have a -9 in the brackets like that, it means to input -9. So input a -9. So what is -9 minus 1 over 5? What'd you say? What did you get on the top? Did you get an 8? What is the top? -10 divided by 5. -2. Okay? Is that okay? I added one more step. So on a test, you would see like something like that. Okay. What are the rules of an inverse function? The domain of the function. So, what does domain talk about? Do you remember the word domain? Talks about the x. So the domain of the function will be the range of the other function. Does that make sense? Because whatever you have as x values will be now be the y values on the other thing. The range of a function will actually be the domain of the inverse. Okay, what is the domain and range of the original here? What's the domain? What's the farthest left? -4 to how much right? Infinite. Infinite? How much right does it go? It keeps going, going right. What's the arrow's going right. What's the range? What's the lowest? -2. What's the highest? Infinite. The arrow says it's going up.
But if there was no arrow, you wouldn't do infinity?
If there was no arrow, if it stopped there,
Yeah.
it would be 2. Yeah. Okay, let's graph the inverse. So for instance, -4, 0, where are you going to put it? Zero, -4?
Why would you move to Z?
I switched.
Oh, you switched.
I switched the coordinate. Okay, this coordinate is 0, -2. So now where are you going to graph it? -2, 0. Can I take the arrowhead point, which is 2, 2? What are you going to put it? 2, 2. It doesn't move. Can you connect these 3 points? And where are you going to put the arrow? Does that help if I kind of expand it, maybe?
Why would you not do like the same with 2, 2?
Yeah, it did. It stayed there, 2, 2.
It didn't move.
It didn't. It stayed. It didn't move because 2, 2 switches to 2, 2. Okay. I don't know if you can see my graph. Mine's yellow. Okay. Ready? Inverse. Can you tell me the domain of it? What's the furthest left this is? -2. What's the furthest right it will go? Infinite. What's the lowest my yellow graph is? -4. What's the highest my yellow graph will be? Infinite. So, did our prediction, the domain of this should equal the range of this. Did that work out? Yep. The range of this should equal the domain of that. Okay. Write the range of the inverse if the original had these points. So, the range of the inverse would equal the what? Domain of original. Okay, so now I'm just going to show you one weird thing in math that you've probably never seen before. I'm going to just make a list. So in math, if you make a list of stuff, you put these types of brackets on. So what will the y values be? My new y values will be the original x values. Whatever I had originally for x will be my y's on the other one, right? And I'm going to list them, and I'm going to list them in chronological order like that. Okay, and then this stuff, I think I'm going to do one of those lovely things where I omit another outcome to learn, because we don't have to worry because it's no provincial.